This can be given by the kinematic equation S equal to ut plus half at squared. Substituting values, we will get a time of 2.89 seconds. Apparently, the air resistance is negligible. The time calculated in part 1 is 2.89 seconds. If air resistance is present, the acceleration downwards will be smaller than g, and the time taken to fall 41 meters will be larger than 2.9 seconds. The extension of the rope is given by the distance 4 minus the natural length. That will give us 32 meters. Elastic potential energy is given by half kx squared, and k is the spring constant. It can be found from the graph, and in this case is the gradient of the graph, and that will give us k a value of 105 Newton per meter. Therefore, elastic potential energy is half kx squared equal to 53,760 joules. Gravitational potential energy at the top is given by mgh. Now, the GPE, gravitational potential energy, after falling 73 meters is 0. Therefore, gravitational potential energy at the top will be mgh, where h is 73. That gives us 5.37 times 10 to the power 4 joules. Gravitational potential energy after falling 41 meters. In this case, the height will be 73 minus 41 meters. That will give us a gravitational potential energy of 2.35 times 10 to the power 4 joules. Elastic potential energy at the top, half kx squared. In this case, x is 0, so that will give us a energy of 0. The rope has not extended yet. After falling 41 meters, in this case, the rope has not extended yet also, because the natural length is 41 meters. Therefore, the elastic potential energy is 0. Elastic potential energy after falling 32 meters. The extension is 73 minus 41, 32 meters. So half kx squared will give us a value of 5.38 times 10 to the power 4 joules. The kinetic energy at the top is given by half mv squared. After jumping off, immediately after jumping off, the velocity is still 0, so the kinetic energy is 0. Kinetic energy after falling 41 meters. Now the kinetic energy comes from the change in gravitational potential energy. At this point, the rope has not extended, so there's no gravitational elastic potential energy, and also there is no air resistance, so there's no other losses. So the Ke will be 3.02 times 10 to the power 4 joules. Kinetic energy after falling 73 meters. The man come to a momentary stop at 73 meters. So the speed will be 0, and the kinetic energy will also be 0. The maximum kinetic energy is when the weight is cancelled out by the extension in the rope. So the acceleration is 0 and the net force is 0. This happens when the F rope is equal to the force in the rope is 735.75 Newton. That's the tension in the rope. From the graph, we can see that this is at an extension of 7 meters. Therefore, the jumper will have fallen a distance of 48 meters. Initially, all the energy is in the gravitational potential energy, and that was 5.37 times 10 to the power 4 joules. At the extension of 7 meters, the gravitational potential energy will be 1.84 times 10 to the power 4 joules. The elastic potential energy stored in the string or the rope will be half kx squared, and there will be 2.57 times 10 to the power 3 joules. Therefore, the jumper will have a kinetic energy of 3.28 times 10 to the power 4 joules. This original gravitational potential energy less the remaining gravitational potential energy and less the elastic potential energy. So the gravitational potential energy varies with mgh, so it's a straight line. The elastic potential energy of the rope, for the first 41 meters, there is no extension, so the energy is 0, Then after that, it rises with half k x squared, so it rises with this extension of x squared. The kinetic energy is given by the gravitational potential energy in this case, so it rises in a straight line. And after 41 meters, some of the gravitational potential energy is converted to elastic potential energy of the rope. Initially, the extension is small, so the kinetic energy of the man still increases. So at some point, when 48 meters, it starts to decrease, and the total energy at any point in time is given by the sum of the elastic potential energy, gravitational potential energy, and kinetic energy, and that will be 5.37 times 10 to the power 4 joules.